critical facilities. He does everything from labs to equivalent of data centers for these facilities that are interest to us. I met John in 2005 or 6, I think it was, back when we were working on a data center at the Bank of Canada. It's so long ago that they got it. It's gone. Chilled water plant was put in on time, on revised budget, but still. I mean, cranes downtown, big costs, it was a big deal, and tight timeline, but we delivered it. It was very well done. And it's sad to see it go. But John, Jill, please share your thoughts on the challenges of taking those business requirements and translating them into a facility.
Thank you, Neil. Neil told me this was a magic mic, that it would turn on automatically, and I thought he meant the movie, and so, you know, I was seriously disappointed. What can I say? Every time I get a mic and I get up on stage, I think I have to do a comedy routine or sing, but John said he wouldn't do feelings but with me. But anyway, all joking aside, as Neil said, I've been in the industry 30-some years, and my role has been facility delivery, so I've built facilities, and then I've supervised the team that managed them. So I have a long history of being involved right from the beginning to being involved when you're standing in the basement and it's flooded and all the power systems are down, right, on the weekend, long weekend usually, on a Monday. So I have lots of full cycle experience. I've also built and operated facilities all over the world, in Europe, in Asia, in cold parts of Russia, in Africa. So I have experience as well in that area. And over that time, I worked with John as a designer in designing and building those facilities, and we probably worked together 25 years, and we still speak to each other, which is a good sign. And we wanted to share some of our experiences. We developed an approach to specifications and how to make specifications work for you, as opposed to be an area of confusion and conflict.
Yeah, so Jill and I, we go way back in time. By far the majority of the 60 years experience that Neil alluded to. I've got way more gray hair. But we built some really interesting projects together, a lot of interesting challenges, and we've seen good outcomes and bad outcomes in our careers in terms of having specifications that are clear and a process that gets you to an end point where you're achieving what you thought you were going to achieve in the first place when you first got going.
So we're going to talk about specifications and how to be successful with them. And one of the stories I like to tell is when engineers came to work on my team, one of the first things I did was I gave them a grammar book. And they would look at me kind of weird, like, what are you doing? And I'd say, this is the most important book that you'll ever have. Some of you may know it. The panda eats shoots and leaves. Where do you put the comma? Right? Totally different outcome. So what are the considerations for success? An approach that we've taken from industry. I've worked in industrial sector, I've worked for crown corporations, I've worked in the provincial public sector. So, you know, different approaches in different groups of owners, and this particular approach has been really successful for me and with John. And then how do you have a team that functions? I think Ryan touched a bit on that. What are the characteristics of a team that's going to get you the results you want? And then what's good practice, and then opportunity for questions. So specifications, issues. Why do we have specifications? What are they for? Whose responsibility are they? Are they just the designer's responsibility? You know, where does the rubber hit the road when you're building it, when you're operating it? So really they're a way for the owner, designer, and construction team to communicate, to try and make clear what's required from both what is the physical thing you're building and how it operates. When they're not thought out and detailed, in the end it's the owner left with the problem. So I've worked in the public sector, even in the private sector, when we talk about risk transfer, transferring the risk from the owner to the designers, the philosophy will we're not experts, owner aren't experts, the experts should design it. And then, even better, we get a facility management group, an FM group to manage it, so even as owners, we don't have to run it, so we just transfer all that responsibility to you, the experts, and that will make things better for us. But in the end, I've been the owner, I've been the liaison with the FM group, I've been left with the issue in the end. The owner has to live in that facility, has to make decisions every day that will be affected if their wishes aren't clearly understood. So I think there's a fine line between risk transfer and abdication, and how do you put that together in a way that meets the owner's needs, but also gets the experts involved.
So we've all seen situations where you've got foggy specifications, clear in your own mind as to what you want, but what you get in the end is a system that just doesn't perform well for you. We'll see it in the data center marketplace a lot in the sizing, oversizing, undersizing of cooling systems, power distribution systems, fan systems. The biggest issue that we've seen often is in startup. You're trying to get your systems going and validated. You're in an operating mode, but you don't have the load you need. You've got a chiller plant that's too big. You've got generators that are too big. You've got fans that are trying to chug away at too slow. And then you need to expand your space. And you think, well, I've got space for another chiller, I've got space for another generator, but it turns out you've configured it so you actually have to shut down the whole facility in order to install that equipment. You haven't thought far enough ahead to understand what it takes to actually get that implementation done when you're ready for it.
I've had some great examples where we've got great redundant electrical systems facilities, but actually our emergency power system, there's no redundancy. So you think about it, at some point I got to maintain my emergency power system, but I can't turn my emergency power system off because I need my emergency power system because I'm operating. I didn't put any redundancy in my emergency power system because it was the redundant system. So there was no thought about how do I actually change out those switch gears in my emergency power when I need to. Right? Great, I can get a backup gen, great, but my distribution is shut down. So that it doesn't help me. So those type of considerations.
So this is a drawing that Jill brought along. It's just, many of you have seen this before. It's what happens when there's a lot of clarity issues in terms of reading, reviewing, understanding what's actually being specified. You know, you're looking for, at the end, what you're looking for is this, just a tire swing for the kids to play on, but somebody's put it in a specification that looks like it does up on the upper left. And you work your way through a process where you get designers looking at it, engineers looking at it, and then it gets installed in the field, and like the only way to make it work is a way that it won't work. And the simplicity of the objective is lost in the cloud of all of the discussion that goes along the way because it's not thought through.
So from an owner's perspective, what am I thinking about when I'm putting together my specifications, right? Some of the basic table stakes, that it's reliable during regular use, right? Regular operating use, it runs reliably. And you would think that would be pretty easy. But when you start getting into considerations like Ryan was mentioning, when we as owners, we're not a monolithic piece, we have our own internal battles, want everything sized up for future expansion so it doesn't run reliably for the first 5 years because you're so oversized, for example. You want to make sure that you're able to deal with unforeseen or disasters, floods, power interruptions. And some of the nuclear facilities that I was looking at, being hit by aircraft, for example, various different unplanned events, that those are basically planned in your specification. Ease of maintenance, as well as thought to how things will be maintained. Often the thought that goes into ease of maintenance is, well, let's just make sure we can get at the access doors. Well, it's more than that, right? It's how are we going to maintain it, who's going to maintain it, what's going to need to be changed, is it changeable when it has to be done. And then other considerations that owners have, we're talking a little bit about, Ryan was talking about the delivery mechanism. Do I want to transfer risk? How do I want to finance it? What's the best delivery vehicle for me? Is it triple P? I've had experience with that. Is it step lump sum? Is it construction management, where I have more control because the outcome is more important to me? So when you look at owner types, I have worked in a number of different institutions and industries. They're different, right? So if you look at the industrial application, there's a lot, it's my experience, there's a lot more expertise within the company that is working with the design firm. When you start to get to some of the public sector, depending on which part of it there's been an outsourcing of the expertise. So the owner themselves don't have enough expertise to be able to communicate with the designer, to ask for what they want in a language that the designer can understand. And when it's actually built, there's issues that happen that then the cost transfer to the operation side where those have to be corrected. In the public sector, I've been on project teams where the procurement team is bigger than the technical team, right? So the transparency is important, meeting broader public service guidelines are important. There's lots of focus put on that, but there isn't an investment in actually understanding the what. It's all about the how and the process, and you need a balance there.
And that comes back onto the design team where you're being selected through a process that ignores the capabilities of the team and looks more at price and the transparency and the fairness around the cost of the services as opposed to the value provided by the team. So from a designer perspective, I've always said this to my clients: the smarter the client is, the better the outcome of the project. The more they know about what they want, the more they understand the critical elements of their operation, the more in detail they can go in the discussion and description, the better the project's going to be. And being overly prescriptive as a client coming to a design team can be of a tremendous benefit. We've worked with outfits like Digital Realty building data centers for them, and they have a design guide that's very detailed, and it's a start-to-end design guide where we're sort of in the middle. They understand what their operational requirements are, they understand what their performance requirements are, they understand what how the commissioning is going to go together. They actually run all of that front to back, and we're in the middle providing the design interpretation for the contractors to build it. So we're there starting with somebody that really understands what they're doing and what their objectives are, and at the end of the day we're able to deliver a project much more effectively at a better cost point and with a better financial and operational outcome than we would with a client that just comes to us and says, well, I kind of want a data center, and where we have to tease out all of the issues and frankly have to make a lot of decisions for them that in the end may not be reflective of what they really need as an owner. And we find the biggest challenge in those situations is they'll often put in front of us a project manager with no real technical expertise, an administrator, somebody that can ask questions and write down answers and put together schedules and hold everybody to account to a contract that isn't very clear and has a lot of vague requirements.
So this is the approach that has been successful for me in the past, and it's a systematic look right from the beginning to the operating delivery of a facility. And when you start on the left-hand side, you see really what is a clarification or further clarification of specifications. So if you think a little bit about what Denis was saying on the spec for the open concept rack, what they had there, and not using tools, data cables must come out of the front. Those are functional design specifications, and the user requirement that preceded that would be that you didn't want humans in the hot aisle, for example. And another one might have been you want maximum energy efficiency, and one of the functional specs of that might be the ability for the rack to be sized to take the larger fans, for example. And then from that, you get down into, well, what does that look like? What is the actual schematic? What is the actual detailed drawing? How's that actually penned out? And what happens often is the functional design part is the part that is missed or is not spent a lot of time on. So as a user, I might say, I need to meet FDA guidelines, I need to meet fire code, I need to meet building code. But what does that actually look like? Because there are often trade-offs between the various regulations that you have to meet. There's always trade-off in every design. And if the full team isn't involved in that trade-off decision, the owner often doesn't know or might have made a different choice than the designer constructor would have made. So on this left-hand side, we're detailing out what we want, and then we're going down into implementation, which is build. You construct it. Normally what happens, design, lump sum, build, it's constructed and commissioned, and the constructor commissions it. In this, there's a more detailed verification that you got what you wanted as an owner. So, did I get my detailed specification? There's an installation qualification, which is really a more detailed commissioning. I ordered a fan of this size, of this shape, of this motor size. Did I get it? Check, check, check. Does it have an access door? Check. Very simple, right? Operate. Does it operate as I wanted it to operate? Look at the functional spec. Do I have the right number of air changes? Does it keep the humidity in the range that I want? Does the alarms from the servers go through the rack and actually go to the building management system? Right? So does it operate the way that I want it to operate? Often what happens when there isn't this type of verification, it comes to the facility management team, which would have been my other hand, and nothing works. The air handling units are tripping off, the temperatures are going up, the fans aren't turning on. This is when you discover that, you know, the ducting was ducted to the wrong room. You know, the actual shut-off valves aren't in place. All sorts of things that would seem very rudimentary, but happen time and time and time again. Because there's no active verification of the operating of the units, if you like. And then finally, the performance qualification. And that's one level higher. Does the whole building run the way it's supposed to? Does the security operate the way it's supposed to? Do the door interlocks work properly? Did the chilled system actually operate with the process equipment as well as the facility equipment? So again, it's a holistic approach from the beginning to the end that the function actually happens. So the user requirements are generally developed by the owner. They'd be the business requirements that Ryan was talking about, right? What do I need at a high level as a business, right? The functional requirements are jointly developed between the owner and the designer, and it's important that the owner be involved in that because that's where trade-offs are going to happen, and you as an owner want to be aware of those trade-offs.
And when you've got an owner with a lack of a technical capability, that hinders the process because it becomes more of a one-sided conversation. And we don't get necessarily the benefit of how the facility is intended to really operate. We have an idea, we have it based on our own experience, but we don't necessarily understand the nuances of what the challenges are for running the facility.
And this is an important point when you do value engineering. So we've done all the detailed design, we've gone out for prices. Oh gosh, it costs a lot more money than we thought. Happens every time. So let's do some value engineering, right? So now we're making trade-offs, right? And where does that go? And if you come to the functional specification and you have those discussions, for example, our chillers are too expensive, we're going to change from stainless steel, which the maintenance guys wanted, to galvanized because it's a couple $1,000s cheaper per unit. Woohoo, we saved X thousands of dollars. But all the operational guys know in 4 years we're going to be changing out those galvanized steel chillers because they're going to have rusted out because the actual operating conditions are, they're on the roof, they need to be serviced, we're throwing 5,000 tons of salt down because this is Ottawa and there's winter 8 months of the year, right? So those kind of discussions, if they happen, there's not what I call a false economy of capital. So you're trading your false economy and your capital dollars into your operating dollars. And in triple P, the argument always is the owner, that's not my problem, right? That's the provider's problem. If they're doing the FM, they can pay for it. But in the end, I've been a triple P operator, you know, someone else is doing my FM, but I as the owner want to do a move, want to move a door. But my FM operator is losing money. It's going to charge me 100 times what it really actually is to move a door. So I'm not going to move that door. I'm going to reroute all my patients, I'm in a hospital, in convoluted ways so that I don't have to pay $25,000 to move a door because I can't choke that down because I know it's way too much money. But they're trying to make up for their expanded cost on operating because during the triple P, the constructor, who was the lead, basically stripped out all of the things that would have made the operating complete. I know, Ryan, the theory of triple P, but I have the experience that, you know, the stronger player in the triple P is generally the constructor, and there's a drive for speed, and the drive for speed keeps the time for some of the maintenance considerations really small, and they don't get dealt with.
And the only other point I'd make here is that when you do see a scope change in the project, you need to go back to this functional requirements document and revisit the entire genesis of the project. Major scope changes have big impacts on system selection and on direction of the projects. So you need to go back. You can't be doing that just during a design phase and assume you can just carry on. So in the detailed design phase, this is, of course, is led by the design team. We're meeting with owners. We need to meet with their operations team. It needs to be done in a collaborative format where operations people are discussing with the design team the operational challenges that they have, what they're expecting in terms of the maintenance processes, and so that those can be built into the documents. It's not enough to just have submissions and get them to mark up and send comments, and you really need to have working meetings with these people. They have a wealth of knowledge that can really be a benefit in providing a set of documents that will generate a building that they can live in and thrive in as an owner.
Well, one of the things that we've seen is actually doing this early enough, like at the 30% drawing stage, actually drives down your costs, because you'll find the operators, for example, only use 60% of the points that the designers would love to put in from a controls perspective. Well, yeah, on this temperature, this VFA box, and the operators actually, I don't look at that data, right? So you can reduce your point cost greatly, for example. And what normally happens is the operations folks get involved in the 90% complete drawing phase, and by then it's too late. Everybody is so invested in the drawing set they have. They've already got the date to build it. We're 90%, we're not going to go back and move that air handler, we're not going to go back and change that. So it's actually a false consultation, if you like. So once you've gone through and you've got your detailed design, this is the spot where you want to go back and just qualify that it's going to do what that you expected it to do. And all of these returns to check back that it meets your user requirement, they chafe at people. It's like, we'll just skip that step because we're ready to go. But what we found in practice is we catch things at these stages that if we didn't, when you were actually doing your construction, you end up doing those really awful things you hate to do, where you basically have to tear down walls because you don't have access to access doors. You have to cut holes in fire separations. You have to add a whole bunch of structural reinforcement to your roof because you weren't, you missed that you needed additional rooftop units, and they cost you a lot of money and take more time.
So the implementation, of course, that's the construction phase. Having consultations with the constructor along the way through the design process can be very helpful. Joe mentioned the construction management process. That's one where you can facilitate that rather easily within the P3. Obviously, the constructor's there along the way. And the owner really needs to take an active role in this process. There are always considerations to be made when material selection options, there's delays in delivery of equipment, you have to go with an alternate supplier. The owner needs to be conversant with the challenges associated with some of these changes and be able to provide some input as to whether they can be tolerated, which of the A, B, or C options will work best for them, and not just drive it by cost or what we think is the right answer. And then post-construction, of course, the straightforward commissioning process, which of course is anything but straightforward. It's an extremely difficult challenge to implement correctly. It takes a lot of effort, and it's often given very short shrift by the construction community in interest of getting in and getting out. It's something that is we often implement through an independent third party, which provides a little bit more surety around those processes. And then we follow up in this industrial process with the installation qualification, the actual physical verification. You go through with your checklist, verify that the installation was actually done It's more of an enhanced commissioning process that we're following here. And then the operational qualification and the performance qualification that Jill described are implemented at the end of the construction, and then the facility can be signed off, usually within 12 or 14 months of completion of construction, once you've been through all of the seasonal startups and shutdowns.
So what's a successful or good approach to building your specialty facilities, right? I think for me, integrating the design team, including your operations people early, is a successful approach. And ensuring that you have, as an owner, the right skills to be able to speak the language and understand what your designers and constructors are telling you. Often I think owners agree, especially in the public sector, when they don't really understand what they're agreeing to, right? Various ways of communicating. Not everybody can read 3D drawing sets, and especially when you're looking at owners, if you've got people who aren't engineers looking at them, if you're able to do mock-ups, if you're able to do 3D visual fly-throughs, right? So that you're able to have people understand what they're seeing more readily. And then creating a verification or validation plan at the end, so that you're not, I can't tell you how many times I've gotten facilities as a operator that I haven't received the owner's manuals, I haven't had any trainings on the systems, and they're operational, and they're not working, right? HVACs aren't working, pumps aren't working, temperature's off, and the operations team is left to try and figure it out. I think Neil was saying something at the beginning about facilities, 10 ways to die. I used to think of it as 10 ways to cry, especially when you started them up.
And we've seen examples. The drawing review process that we often rely on. We've seen examples where clients will hand drawings off to subsets of their own team and say, review these drawings for this lab, let's say, and let me know if everything looks good. So it turns out at the end of the process, when we're doing the construction and nothing fits, none of the power outlets are in the right location, but we followed the markups, you find out that the people that were reviewing the drawings couldn't actually read the drawings. They saw an outlet symbol and said, well, yeah, an outlet, that's good, but it's, they needed a three-phase 240 volt outlet, and we gave them 120 because that's what the symbol was. And we found out that they didn't know the difference. They just thought a symbol was a symbol was a symbol. And so it's really important to have those conversations, and this is where doing design presentations as an integral element of the review is important. So you have an opportunity as a designer to look the people in the eye and make sure that they understand what you're telling them. And when they don't understand, and you'll often find that they won't, you can then at least build a process around educating them and getting the information out of them. What we ended up having to do was we actually had to go back into the lab with the lab people and do a full mock-up and determine for them what they actually needed. Look at all of the equipment. We had been told that they understood what they needed and they'd be able to mark up the drawings for us, which they weren't able to do. So there's these huge hidden challenges that you have to be aware of when you start putting these facilities together.
And they did understand what they needed, but they didn't understand what you needed to know about what they needed. Right? I need a fridge, and I need a fume hood, and I don't know what that means in terms of power. That's the engineer's job, right?
So that's it. Any questions?
I just want to thank everybody first, and we'll pass the mic around. Thank you very much to both of you. Your perspective on this in a different way of, okay, now we've got requirements, but how really useful are they? And how can we best make it so that your facility is actually going to be useful to you for the next 30 years, 25, 30 years, because buildings last that long, hopefully. And it's a big investment. And if I'm, for example, in that space and I'm giving you requirements, I'm hoping that it'll meet my requirements and be able to change with me as I see fit. So I see that complexity very much, and I'm very glad you guys were able to speak to it. I'm going to pass the microphone around on this side. Carrie, I think you've got a question. I see another one over there too. Hang on.
Hi there. You made mention of technical PMs versus administrative PMs. What are the skill sets that you would expect to see from a technical perspective, those type of participants?
All right. Well, from a design perspective, you probably got your own on it. From a design perspective, it's really having somebody that is familiar with the operational challenges of the facility itself, what they need to get out of the facility and how it operates. They don't necessarily have to be fully versed in the design process itself. It's really more understanding of what they want it to be in the end, how they want it to be configured so that it works for them.
Yeah, so where I see the rubber hitting the road there, if you've got what I call an administrative PM, I'm there to manage the schedule, to do the reports, to give you the finances, but I can't make any technical calls. Because in the end, as the owner, there's going to be disagreement between the designer, between the constructor, between myself, and somebody has to make a call. And if I don't understand my business enough, so I have to understand my business, and then understand the technical language. I don't have to be an expert in electrical and mechanical, but I have to have some understanding of how the systems work.
Yeah, it's always complex to deal with that challenge, and I think, one of the facilities we worked on, John, I remember you were questioning some of the description of the requirements, and at the time it was very complex for even myself to describe the true requirements as we needed it, from a technical, translating it to a facility or into drawings really at the end of the day. And always a learning experience and always fun, but that is a complexity. And I think we have a question up here, and I'll bring it down over here. Hang on.
Thank you. My name is Akash Sinha. I do a lot of project management and construction. I can relate to a lot of the challenges that you're showing here. Specifically with data centers, I was wondering, often I have to face where you got an owner that wants a lot of work done ready to bring in a construction team or a builder yet. And so you don't have that expertise on the team yet, but you got to try and invest a whole lot of energy into getting a business case put together for the facility. How do you guys deal with that until you can find who the correct construction team or builder will be? And I assume with data centers, there's a very limited pool because of a lot of the sensitivity that's required for that particular sector. How does that factor into the whole getting to that stage where you get that expertise on the team?
Yeah, and as an owner, I've had that issue where I needed a constructor's perspective as we start rolling out the design. Sometimes for pricing, because I never trust designers' pricing. I need a constructor to price it. Really, I would go out to constructors that I had relationships with and get their perspective, right? So ask them early on the team. And you have to be careful there, so there's issues about however you're planning to tender it in the end, if it's triple P, if it's design build, there's preference, so I try to pay for that, right? So pay for constructor expertise to come in and do commenting earlier on in the design.
Can I just add on to the facilities portion of it, because you mentioned the P3s that sure the constructor's probably the bully in the room, right? Trying to get things pushing through faster. But you talked about an integrated project team or review team, I guess, and you need to get that facility manager on, but you don't even have a facility built. It's probably pretty tricky to get someone to come in and actually provide you that service.
And the best circumstances, I have it in-house.
The best circumstances, I have it in-house. So that particular build might be not an FM that I'm doing, but I have other facilities. I have 5-6 million square feet. I have other facilities where I have FM I can bring to that team, or I hire people in early. Usually the constructor has their team, right? So if they're there designing, it's a team that's already set. You require them to bring the FM in guy in early.
But are they bullying, like you say, there's the contractors, even though the contractor and the FM provider are on the same team, are they still bullying them into a cheaper project,
My experience is yes.
Yeah.
And so as an owner, if I know that's happening, I can turn a blind eye and say it's not my problem, because the FM guy's got to operate it, not my problem. but it will be my problem.
The
So,
changes, right? They all come back to you.
so you can try weighting it differently in your procurement documents. You can try putting a requirement in your specification that says you need to have FM at this point and it needs to be given this. And then you've got to watch and intervene. So you've got to manage your suppliers or your team and say that that's not acceptable. But it's difficult. I have to say, it's not my favorite vehicle as an owner or operator. I don't like it because I have very little control over what I'm going to get. And I have very little ability to implement the process when it's underway. I had a triple P happening on one of my facilities that had to hook into existing supplies and services on the rest of my facility I'm managing. And, you know, the triple P team isn't getting paid until the end. And every day that I don't do a shutdown to let them cut into my services, they're jumping up and down in my head because they're not getting paid, right? But I'm putting at risk all the rest of my facilities, trying to do things quicker than I would like to, right? So it's not my favorite vehicle, certainly.
Seems like a big juggling act, really. You know, Ryan and I have been fortunate. I was the middleman trying to understand and digest requirements on a project with Ryan, so I think that's probably burning a hole in his heart, maybe a little bit from my troubles that I've caused him. You okay? You? Yeah. 100%.
Thank you. We've all been involved in projects that have a shoestring budget and needed to start yesterday. How have you approached difficult conversations with owners or customers that want to avoid or rush through or don't pay enough attention or don't see the importance in having thoroughly flushed out and approved specification documentation? And the second question is kind of related to my first question is, it's always tough having conversations around contingency and having contingent design and construction budget and also in your operating budget. How have you had or handled those tough conversations?
Maybe I'll let you talk about contingency. That's right, there you go. So when we get into a project situation where it's ill-defined, but there's pressures to move forward, if you don't have a mature enough client that understands that without clear documentation to derive a program from, that is being developed along the way, that you're going to be spending a little more money and you're going to be taking a few more risks along the way, and there are going to be changes that will have to be implemented in the field. We've done it successfully with defense construction in the past, where we normally it's about a 2-year design cycle for a major implementation on defense construction, but with some of the defense procurements being advanced to try to support some of the military objectives that the Canadian military are focused on, they've fast-tracked a number of projects over the years. And one of the fast-track methodologies we worked with them to develop was this. It was a phased implementation approach where we understood the fundamentals of the project, so we were able to design the fundamental elements. And while some of the detailed requirements were being fleshed out, we made some best guess estimates as to how big systems might be, cooling systems, heating systems, space allocations, all of that. This happened to be in an advanced training facility. So there was a very high IT load, a large computing load that was ill-defined at the time that we were starting the construction. So we ended up implementing the project in phases. And we had the client understand that it was going to cost them more money. We'd be able to shorten the timeline, and we'd be able to get people moving effectively. And what we did is we put placeholders in for things that we didn't know. So the placeholders ended up being plus or minus within 20% of what the final requirements were. So when we went to the next phase of implementation, everything that was in the contract was about 20% either oversized or undersized for what the requirements were. So we issued a change order to the contract that upsized or downsized as required. So it ended up being a change and not an add. So it was a much more cost-effective approach to take rather than just saying, well, we don't know, so we're not going to specify the chillers yet. We spec chillers. Chillers had to get a little bit bigger. Well, actually what we did is we ended up adding the second one. And then we had space to put additional cooling in the training rooms. We had a base building cooling system that we thought might meet the load, but we put in provision for additional spot cooling, which we then finally sized and added in as a change order. So that process actually allowed the project to go from design initiation in December to we were in construction in September, and we were open a year and a half later, which was a record time for a D&D project. Typically, if we started in December, it'd be 18 months later on that we'd actually start construction. So we were able to shorten that cycle by better than 12 months, and then the construction cycle was reduced by about 12 months as well. It ended up being a tremendous success.
Well, you guys, thank you very much. I think if I can say anything. Oh, sorry, Jill's got to add. Pardon me, please.
Just on contingency quickly, this is my favorite topic. So contingency, my favorite is, it's always 10%. Doesn't matter what you know, what you don't know. A lot of numbers is 10%. I laugh. I always talk about contingency when I talk about it as an owner to my management or my constructors. It's two things. It's to cover what I know costs more than what I thought it was going to cost, and what I don't know. And the what I don't know percentage contingency is based on how many details I have about what I want, right? So when I have a sort of ill-defined project where myself as an owner, my management team doesn't know what they want, or I will throw big numbers. If you don't know what you want, if you only know 20% of your requirements, put 100% contingency on. And they'll go, what? I said, well, you don't know. You don't know, so you're asking me to quote on what you don't know. If what you know fairly well, put 10 to 20. When you get to the part where you don't know what you're doing, 50%, 100% wouldn't be unreasonable. And you can get data from that. If you look internally at your project performance, I think a lot of people would look and say, well, I'm over by so much. You can look back and say, this is my project performance in the past. I was 50% over here. I was 60% over here. Here's why. Right? So kind of splitting it between the two things. What do we know? How well do we know it? And what don't we know?
You know what, we are close to, like, holy moly, 40, 50 minutes coming on, but I think this is an amazing topic. It's just the complexity of dealing with awkward requirements or unclear or ambiguous requirements, however you want to call it. I think in some of the cases we're seeing these days, it's claimed that the information is of higher classification possibly, or not shareable, and that just puts complexity in your design at the end of the day, and challenges. So we see that in some of the sites, and thank you very much again for sharing how maybe some of our other projects coming forward might be able to survive some of these longer term projects that need to get delivered for facilities. Thank you very much, guys.